Hello everyone, in today's video we will discuss some introduction for exercise 2.3. Okay, so in the previous video we have discussed briefly about relations. Now we will discuss about functions. So function is a special type of relations. Okay, so function, what is a function? This is some special type of relations. Okay, so in simple words, this acts like a machine. Okay, means we give some input here and we will get output just like that. If we take this machine, changes the number as a cube of this number. 1 cube will be 1, 2 cube will be 8, 3 cube will be 27. So this is the work of a function. Like if we give some input, we will get some particular output according to this machine. If here is x square, then it will changes to 1 changes to 1, 2 changes to 4 according to the machine, according to the functioning. Okay, so we can take some other example. Like we have in your classroom, we have 3 switches. Okay, A, B and C. Okay, so A switch is for light, B switch is for fan and C is for AC. Okay, so is it possible that by A switch we can switch on light and fan at a time? So function is this type of relation. This is a relation, we know that A is related to light. Means if we switch on A, the light will be on. And if B, fan will be on. Switch on C, AC will be on. Okay. So this is a relation. Okay. And we can't say that if we switch on A, light and AC will be on. So this is not possible, because this will confuse us, this will confuse the students, this will confuse everyone. Okay, so this is not possible. So this particular type is called a function. Okay, now we will discuss about definition. Okay, so what is the definition of function? Let x and y be two non-empty sets. We have two sets x and y. A subset of x cross y is called a function if for every x belongs to x, there exists y belongs to y such that fx is equals to y. Just like that. Okay. For every x belongs to x, there exists y belongs to y such that fx is equals to y. Just like that. F of 1 is equals to 1. F of 2 is equals to 8. F of 3 is equals to 27, because here fx is equals to x cube. Now let's discuss about image and pre-image. The unique element y of y is called image of x under the function this. It is denoted as fx. The element x is called pre-image or inverse image. In simple words, if we have this function f from x to y, okay, the unique element y, the unique element 1 is called the image of this element. Okay, and it is denoted by f of 1. So this is the image and this is pre-image. Okay, so 8 is image, 2 is the pre-image of this. Okay, so the element x is called pre-image. These x are called pre-image and these are called the image. Okay, now what about domain and range? In last exercise we have already discussed what is a domain. Domain is the set of all elements of x. And what is range? The whole set y. If f is a function from x to y, then x is called the domain of function f and set y is called the range of function f. So here with this example we can observe this is domain and this is range. let's discuss about question number 1, which is which of the following relations are functions? Give reasons. If it is a function, we have to find the domain and range. We know that a function is a special type of relation, and we have relations are given. We have to check these are functions or not. Okay. So first one is this function. Okay. So we have this type of situation, like f is a function from x to y. Okay, so elements in first set are 2, 5, 8, 11, 14, 17. Elements in y are 1. Every element is related to this element. Okay, and we have already discussed that we can't have this type of situation in functions, like 1 goes to 2, 2 also means no element have more than one image. Every element have unique image. Okay, so we can easily observe that no two ordered pair have the same first component. So this is a function. Now we have to find the domain. What will be the domain? Domain is this set, means first component of this. This will be 2, 5, 8, 11, 14 and 17. And what will be range? Range will be only 1. Let's discuss about part second of question number 1. Here f is this. Okay, you can easily observe that first components 2, 4, 6, 8, 10, 12, 14. So no two ordered pair have same component. So this is a function. Okay, so this is a function. So what will be the domain? If this is a function, we have to find the domain. So 2, 4, we will write first components 2, 4, 6, 8, 10, 12, 14. Okay, what will be the range? Range is 1, 2, 3, 4, 5, 6 and 7. Okay, now what about part 3? Here first element is repeating. Okay, so we have two ordered pair in which first component is same. So this is not a function. If this is not a function, then we don't have to find the domain and range of this function. Okay, so here we have this condition. 1, 2 and 3, 5. Image of 1 is 3 also and image of 1 is 5 also. This is not possible because by the definition of function we can observe that for every x belongs to x, there exists unique y belongs to y. This symbol is denoting unique. Okay, such that f of x is equals to y. Okay, and here this is called pre-image and this is called image. Okay, now let's discuss about question number 3. A function f is defined by this. A function is given, we have to write down the values of f of 0, f of 7 and f of minus 3. Okay, here f of x is equals to 2x minus 5. If we have to find f of 0, simply we know that here value of x is 0. Okay, we will put x is equals to 0 here. F of 0 is equals to 2 of 0 minus 5, which will be 0 minus 5, which will be equals to minus 5. Okay, what about second part? F of 7. So we will put 7 as x. Okay, we will put x is equals to 7. 2, 7 minus 5, which will be 14 minus 5, which will be equals to 9. Okay, now what about third part? F of minus 3. We have to put x is equals to minus 3. 2 minus 3 minus 5, which will equals to minus 6 minus 5 is equals to minus 11. Okay, so So students, in this video we have discussed about introduction and question number 1 and 3. Question number 2, 4 and 5 are pending. In the next video we will discuss these questions. So stay tuned. Thanks for watching.